All right, so I had question 2.2, and the problem reads: in an amusement park, riders sit on a small seat suspended by ropes of length L that are attached to a rotating disc of radius d, as indicated in the diagram. As the disc spins, the rope, initially vertical at rest, makes an angle theta with the vertical, as shown in the second diagram. The speed of the rider v is constant but unknown. For a rider in C, a total mass m, determine the magnitude of tension in the rope. Your answer should not depend on the unknown velocity of the rider. All right. So you have F net is equal to Fg plus T. We know this because we were supposed to set up a force equation for this problem, and I was able to get this by setting up this free body diagram right here. And I was able to do this because I drew the tension at an angle, and then I have the box which represents the system of the person on the seat. Then I have the force of gravity acting downwards on the person. So once we have this, from this free body diagram, we can set up our equation of F net is equal to Fg plus T. And since we're not accelerating in the y direction, we're going to F net equals 0 equals mg, which is the force for gravity equation, plus t cosine theta. And we got t cosine theta because because the tension force acts in the y direction, the y component, and that is represented by cosine of this, by the component adjacent to the angle. Now, what we do is we move mg over to the left side of the equation. So you have negative mg over cosine theta equals t cosine theta. Then once you have that, we divide by cosine theta, divide both sides by cosine theta to isolate the tension. We have t is equal to negative mg cosine theta. T equal negative mg over cosine theta, right? And the problem asks for the magnitude. So that's why we just slap these absolute value signs around the mg over cosine theta. And this should give us our final answer of t equals to mg cosine theta. And this equation represents the magnitude of the tension force. Thank you.